question 1.12 says if the current flowing through an element is given by all these equations, plot the charge stored in the element over the time period from 0 to 20 seconds. Okay, so we'll do this into 4 sections. All right. So, and remember the relationship is d of qt, dt give us I of t. So if we take the integral of I of t, right, from time 1 to time 2, then they will give us q of t. Now remember, because we're doing integrals, there is a constant, right? There's a constant. And usually we choose the very first constant that's like happening at that interval. So like the first interval will be 0, the second interval will be 6, the next will be 10, like where it started, right? That's what we're trying to find out. Okay, trying to add in, because you know, if we take the integral of that one, it disappears. So we'll have to add that in when we do that. Okay, so the first one, it's 3ta, right? A is just the unit. So if we take the integral of 3t from 0 to 6 plus q of 0. Q of 0 is just 0, right? Because 3t, when t equals 0, is 0. Okay, so we do that. So this will become 3t squared over 2. And if we plug everything in, it would be 6 is 36, so it would be 54 ampere. I mean, sorry, coulomb stored, right? This is, excuse me, this is T6. And the next one's 18. Okay, take the integral of 18, and from what, 6 to 10 seconds, right? And then this time we'll say q of 6, right? Because that's when this integral started. This changes happened, so we'll add that as a constant. And all right, so we say the integral would be 18 t, right? 6 and 10 plus 56. So what is that? It would just be, well, 10 minus 6 is 4. 4 times 8 is wait, what's 4 times 18? It's 3, 72 plus 54, and it gives us 126 coulomb, right? Which also makes sense because we're trying to find the charge stored, right? We're not just trying to find, like, if this is the graph, right? This is section 1, this is section 2. Like, okay, we're just finding section 2 or just finding section 1. No, like if we're finding section 1, we're finding section 1. If we're finding section 2, we have to add the whole thing, right? We're finding the entire thing, all right? And we can't just say, okay, we start from 0, because it's a different equation at 0 to 6, right? This equation only exists from 6 to 10, okay? And this exists from 6 smaller t equals bigger or equal to 6 or smaller than 10 seconds. And then the next one, I'll just do over here, negative 12 integral, that one from 10 to 12, and same thing, plus q of 10, right? Charge at 10 seconds, because we have to add everything together. And good enough that, I mean, lucky enough or convenient enough that q of 10 is like it's 2 plus 1, right? So what's stored, which is good, because this is 18. This is 3 plus 2 plus 1 is the total thing stored. Fantastic. So it would be negative 12 times, so 5 minus 10 is just 5, and plus 126, right? So what is this? This is 5, so negative 60 plus 126, this would just be 66 coulombs, right? And this is for 10, this 15s, right? And then the last one, which is 0. So 0 is just 0, right? 0, any integral is 0 from 20, from 15 to 20, and then plus q of 15, right? This is where we started, and q of 15 is 66. So this is 0, and this is 66 coulombs. All right, so awesome, and that's what we have over here. And if we want to graph this, then it's not that hard. It'd just be, this is from 0 to 6, right? And then I'm not gonna draw into like scale. So yeah, this is this, and then what is 18t, so it's increasing 18t, right? And then it decreases like 12, and then so yeah, we know the slope over here is negative 12t, and then the slope here is 0. So okay, so we know this point. This is at 6. So what is that? This is 54, right? And on top of the point, this is 126, and over here is 66, and then over here would just be 66 as well. This is 20 seconds, 15 seconds. This is what, 10 seconds, right? So yeah, and this is 6 and 10. Okay, and this graph should be something like this. You can spend time, I guess, drawing to scale, but this is what the graph should generally looks like. So yeah, hopefully this was helpful, and I'll see you in my future videos. Bye.